Hello, welcome again. We are solving of radiation and matter. Question number 1 from year 2020 is assuming the nitrogen molecule is moving with RMS velocity at 400 Kelvin. A de Broglie wavelength of nitrogen molecule is close to given that nitrogen molecule weight is 4.64 into 10 minus 26 kg. Boltzmann constant 1.38 into 10 minus 23 joule per Kelvin. Planck constant 6.63 into 10 minus 34 joule second. Options are 1.34 angstrom, option 2 0.24 angstrom, option 3 0.20 angstrom, option 4 0.44 angstrom. From the kinetic behavior gases we have average kinetic energy is equal to 3 by 2 kBT, where kb is Boltzmann constant and this kb is given as 1.3 minus 23 joule per Kelvin. Okay, and temperature is 400 Kelvin, and mass of the nitrogen molecule is given as or molecule weight is given as 4.6 into 2 minus 26 kg. Okay, so putting the values we can find out V. So V is your 600 meter per second. Okay, and now we know that de Broglie wavelength lambda is h by momentum, and h is Planck constant, momentum is mv. So h is 6.63 into 10 power minus 34 that is given, and mass is given, that is 4.64 10 power minus 26, and velocity we have found out by equating this kinetic energy and this thermal energy. So velocity is your 600 meter per second, and from this we can find out this 0.24 into 10 power minus 10 meter de Broglie wavelength is this, or in terms of angstrom it is 0.24 angstrom. Okay. Next, an electron, a doubly ionized helium ion He++ and a proton are having the same kinetic energy. The relation between their respective de Broglie wavelength lambda E, lambda He++ and lambda P is option 1 lambda E is less than lambda P less than lambda He plus plus 2 lambda E less than lambda He plus plus is equal to lambda P. Option 3 lambda E greater than lambda He plus plus greater than lambda P. 4 lambda E greater than lambda P greater than lambda He plus plus. We know that mass of we know that the mass of electron is less than mass of proton, and mass of proton is less than mass of helium, because this has two proton in it, and this has mass of proton is always more than mass of electron. Okay, so and the kinetic energy is half mv square, taking omitting half, then mev square will be equal to mpvp square is equal to mhe v square he plus plus, as me is less than mp is less than mhe, so v is greater than vp will be greater than he plus plus, because of this. So the ratio of vp by ve is me by mp root, and ratio of vhe by ve is root me by mhe. Okay, and the de Broglie wavelength is lambda is equal to h by mv. Okay, for electron de Broglie wavelength will be mass of electron and velocity of electron, h by mass of electron by velocity of electron. Okay, and similarly for proton it will be h by mp vp, and lambda e by lambda p will be your lambda e by lambda p will be your if we put mp vp as if we put vp as ve me by mp root, okay, then we get lambda e by lambda p is equal to mp by me root. Okay, so it means as mp is greater than me, so lambda e will be greater than lambda p. Similarly, lambda e greater than lambda e is greater than lambda h. Okay, so lambda e is greater than lambda p is greater than lambda h. So option 4 is the right answer. Next, the surface of metal is illuminated naturally with photons of energy E1 is equal to 4 electron volt and E2 2.5 electron volts respectively. The ratio of maximum speeds of the photoelectron emitted in the two cases is uh, 2. The work function of the metal is, we know that kx minus hv minus pi naught, where hv is your energy of the photon or quantum of energy of radiation, okay, and pi naught is your work function, k max is maximum kinetic energy of photoelectron, okay. So for the first photoelectron, suppose v1 is the velocity and m is mass, and then we can put kinetic energy as half mv1 square is equal to E1 minus pi naught. So it is also as E1 is just 4, E1 is 4, and for a second it will be 2.5, and velocity is possible V2, and work function will remain same because they are falling on the same metal. Okay, so equating this 1 and 2 or dividing 1 by 2, we have 4 minus pi naught divided by 2.5 minus pi naught, and V1 by V2 is given as 2. So the ratio of the maximum speed is given as 2. Okay, or we can write it as 4, and this will be 4 minus pi naught and 2.5 minus pi naught, and cross multiplying 2.5 into 4 minus 4 pi naught is equal to 4 minus pi naught, or 6 is equal to 3 pi naught, and pi naught is equal to 2 electron volt. So the work function of the metal is 2 electron volt. Next, in a photoelectric effect experiment, the graph of stopping potential V versus reciprocal of the wavelength of the plane is shown in figure. As the intensity of incident radiation is increased, option 1, the slope of the straight line gets more steep. Option 2, straight line shift to right. Option 3, graph does not change much. Option 4, straight line shift to left. So this is your straight line, and this is your stopping potential, this is your 1 by lambda. Okay, and this is your angle theta. Okay, when the when the intensity of the radiation is changed, only the number of electrons coming out of the collector surface or emitter surface changes. The velocity doesn't change. So it is changed by your stopping potential. So intensity of uh, radiation doesn't have any effect on stopping potential. So the graph will not change. Okay. So other explanation is, for a given photosensitive material and frequency of the radiation, saturation current is found to be proportional to the intensity of the incident radiation. Okay. And where stopping potential